There are pretty much three semantic models for passing parameters. The first model is known as the in model. And the way that's done is that we have the calling function, right? That's the caller. And we have the callee. And we pass parameters in, right? This is what we pass parameters in, okay? This is known as the in semantic model. The second semantic model we need to talk about is the out. And the third semantic model we want to talk about is the in-out model. Now, what are these models in a sense? Well, the first model deals with passing parameters into the function, which is the function is not supposed to pass parameters out. Now, I'm not talking about return values. Return values is something else. I am talking about using the parameter list in order to pass data out. So the first one is the in model. The second one is the out model. Now you're saying to yourself, who's ever seen an out model? What is he talking about? Well, I don't know if you've seen in C#, for example, you can have a function in your parameter list. You can write out int b in your parameter list. This word out, it's coming to signify this out semantic model. What that means is that data is not being passed in, but what we're passing in is a box to be filled by the function on and then passed back out. And notice again, I am not talking about the return value. I am talking about the parameter list. Right? I'm not talking about the return value, but rather I'm talking about the parameter list. Okay, so that's our out semantic model. And then we have the in-out. In-out is what we've seen in other languages, maybe as a ref, even though it's more than just the in-out model. We've seen it in C++ using the ampersand, the address operator, and others, which in a sense is sending data in and expecting it to be sent data out. And that's the three semantic models that we actually deal with. Now, there are two ways of passing parameters. You could pass a copy of the parameter, or you could pass a path to the parameter. Now, we can go and we can implement these models using each of these different ways of passing parameters. What do I mean? So, for example, everybody knows that what's known as pass by value or call by value. You might have seen the name call by value, call by value. You might see the name as pass by value or other names like that. What is that? Well, pass by value is something that's coming to implement the in parameter passing, and usually it's done using a copy of the values. We're sending a copy into the function. Is that required? Well, no. You can go and you can send, for example, a path and not allow the function to change the value. For example, using the word const, right? So we don't have to implement the in semantic model using only copy in. You could go and say, oh, I could do it using giving an address and just adding the const quantifier, and that would also be an in semantic model. But the call by value is actually implementing the in value, right? It's doing the in, and it's doing it by copying values in. And obviously, everybody knows the advantages and disadvantages. The advantages are that you are working on a separate copy of the data, and that's also the disadvantage, that you have to actually copy the data. The second one implementation I want to talk about is known as pass by result. What is pass by result? Pass by result is exactly the opposite of pass by value, meaning it's implementing the out semantic model. It's implementing the out semantic model, and you are actually just passing a container into the function to be filled by the function. So we already wrote the C# version of out int b. Now notice that what this does is if you try within the function inside to write b or print b or whatever, or use b as c is equal to b plus a, for example, and you did not instantiate b, this would run an error. It would tell you you're using an uninstantiated value. But what do you mean? I actually sent the function with the parameter w. So why is, and w up here was 14. So why is it not instantiated? And the answer is because you did not pass the 14. What you did is you told the system, you told the runtime to use the container b and bind it to w at the end of the function before b is actually rusted in pieces. Before b is rusted in pieces, it is copied out. So whatever value you would have in b at this point in time will be copied into the w. You did not pass the 14 in. All you did is you gave it the rule of how and where to copy out. And that's pass by value, pass by result. Now, the next one we'll talk about is pass by value result. So we have pass by value result. And that's in a sense the copy in, copy out. So it's actually copying in and it's actually copying out. Okay, so those are the three simple models, implementations of the models. And the most famous of them is actually pass by value. The pass by result is less famous, but anybody who programs in C++, C# and other up-and-coming languages have seen that before. Okay, in languages like Ada, you would write in, you would write out, and you would write in out as one word, right? In order to implement all these three models. Now, there are problems with this pass by result and actually the pass by value result. For example, what happens if I write a piece of code that looks like this? I'm going to call the function foo. I'm going to send foo is going to have two out values. Let's say out b. I'm going to skip the other words, and out c. And you call it with f, and you give it w, comma w. Now this is known as an alias problem, right? Because you actually have two names for the same actual variable. So what happened is, if you think about it for a second, is if c at the end of the function gets the value of 14 and b will get the fucking value of 15, well, this thing is undefined. What will be the value of w? Well, undefined, because it's copied out. It depends who gets copied out first, who gets copied out second, and other problems like that. But anyway, these are the three basic implementations of the simple version of the in, out, and in, out. Now, besides these three, we all know and we all have met the pass by reference. Now, the pass by reference that we actually know, grown to know and love in C++ is when you get it with the reference, right? When you get it with the reference variable, it's actually implementing the in-out model. That's what it's actually doing. But it's not really doing that unless you do not add the const quantifier. If you add the const quantifier, then it's actually implementing only the in model and not the in-out model. So it depends how you implement it. But what it's really doing is it's passing a reference to the variables and not a copy of the variable. It's not copying in and copying out. It's just giving you an address to the actual variable. You're actually using the actual variable within the function. Now, as I said, the normal implementation is an in-out model implementation, but that could be changed by actually adding the const quantifier if you actually wanted to do that. Now, the advantage is that you're not copying in or copying out. The disadvantage is that every time you access the variable, you actually it's actually much slower, because instead of accessing a direct address, you're accessing it indirectly. And we've seen when we talked about pointers in previous lectures that every access becomes an additional access. You're accessing the pointer, and then from that you're accessing the actual variable. So how do you decide which version what you want to use? Well, that depends on a whole bunch of principles. For example, do you need passing in? Do you need on passing out? Do you need both? Right? Is it a lot of copying? Is it a lot of copying? So you might have seen things like efficiency as a criteria for deciding what to use. For example, if you're passing in big values, you don't want to copy them, so you might use the pass by reference. But if you only want it to be an in, so you would actually make it a constant pass in, right? You would put the quantifier, making it allowing you not to copy, but to actually pass it in. If the question is runtime efficiency of the actual code, so obviously copying in will be more efficient. I mean, suppose your code inside accesses the variable a lot of times, right? Multiple times accesses the actual variables. So it might be more efficient to copy in and copy out, even if you need an in and out version. But actually, so efficiency is a question of the environment. You know, are we just copying in and touching it once and that's it? And therefore, I'd rather not copy it in. Are we accessing the variables many times? And therefore, I rather yes, copy it in and then possibly copy it out. Things like that. So that's an efficiency question. And then we also have the question of other software programming, programming principles, like, for example, the least privilege principle. The least privilege principle, which you might have learned in the course on software engineering, right? That you do not give access to those who do not need access. So a least privilege principle would mean that you would actually copy in and not give access to the original variable. You could get the least privilege principle working if you actually add the const quantifier. So you ask yourself, why not always use the INOUT? The answer is because least privilege principle. Do not give people access out if you do not need it. Do not give people access in if it doesn't need it, right? So you decide which exact version to use based on the actual rules that and all kind of quantifications that you want to actually use when you decide which of the semantic models you actually want to use.